Myself, Dr. R. Balamurugan, Associate Professor in the Department of Electronics Engineering, K. Rangaswamy, Changodu. I am going to talk about the single-phase rectifiers, its circuit configurations using diodes, and its output. Let's we explore the slides. Basically, rectifiers is nothing but it converts the AC supply into DC supply, and rectification is the basic need for many applications, and it can be done by a single diode or a group of diodes. And there are two types of rectifiers available: half wave rectifier and full wave, based on the rectification process. Let's we see the types of rectifier. The circuit configuration shown here is one diode configuration, which is nothing but a half wave rectifier. You can see the circuit configuration here. First off is nothing but positive off rectifier, and second off is nothing but a negative off rectifier. Here I am giving the input supply is an AC supply, a positive supply and negative supply, which is given through the transformer to the diode circuit. And diode is basically unidirectional device. It allows only current in only one direction. So when I'm giving the positive of supply into the circuit through the transformer, the diode polarity will be checked. The supply polarity is also positive, and the diode polarity is also which is nothing but anode. So both polarities are checked, and it is forward biased, and the output will be coming as pulsated DC. You can see the output in this slide, and this is nothing but operation of the positive of rectifier. Then the same way, when the input voltage reaches the natural zero, and when it is in entering into the negative off, the diode will behave like open circuit. So for getting the output in the negative off side, we are reconnecting the diode, which is opposite to that of the positive of rectifier, and I am getting the output for the negative off side. Positive off side, when the input is given through the transformer to the circuit, there will be no output. When I am giving the negative off cycle into the circuit through this transformer, the output will be coming. So this is the process. So when supply is given to the diode circuit, the polarity of the diode and the supply will be checked, and both the polarities are same, and it will be forward biased, and the diode will be conducted, and the output will be coming through the load side. We can observe the waveform at the load side. Next we enter into the full wave rectifiers. So in the coming slides we are going to see about the types of full wave rectifier with the more number of diodes. So here in full wave rectifier we'll be getting the output waveform for the both the positive off and the negative off. We can see the output waveforms. So there are basically two types of full wave rectifiers are there: center tap transformer connected full wave rectifier, and another one is a bridge type full wave rectifier. Here we are going to say about the full wave rectifier with the center tap transformer with two diodes, one diode for one cycle and another diode for another half cycle. So for positive half cycle, the output will be given through the A diode 1 and load circuit, and for the negative half cycle, the output will be given through the B diode 2 and the load. So I will be getting the pulsated DC for positive half when the diode is on, and next when the negative half is given through the transformer, my output will be coming through the diode 2, and I will be observing in the load. So this is the operation of a center tap transformer based full rectifier. Here both the diodes will be operating for each off cycle. When positive off cycle is given, diode 1 will be operated. When negative off cycle is given, diode 2 will be operated. So these all done by using the center tap transformer. So this center tap transformer will act as a 2 points. For positive of A and 0 will act as a circuit, and which circuit will be closed from A diode 1, then load resistance, then 0 point. Then for negative of it, the circuit will be closed with the B diode 2, resistance, load resistance, and 0. So likewise, the circuit path will be closed and output will be observed in the output load resistance. You can see the operation and the waveforms. Here I have shown the two operations for positive off cycle, negative off cycle, and how the diodes will be behave during positive and negative. So first in first diagram you can see in positive off cycle the output current will be flowing through A, that is positive, diode 1 to load resistance, and the current will be flowing through this direction. You can see the arrow mark which is given. This is during positive cycle, my output will be coming, and you can see the our waveforms here. The output will be coming like this. And during the negative half cycle, you can see here the output diode 2 will be activated and output will be coming like this. And in all directions, diode appropriate diode will be activated based on the input and output will be coming through the load resistance. So for positive half cycle, diode 1 will be turned on, and for the negative half cycle, diode 2 will be turned on, and the current will be passing through for the positive half cycle from A diode 1 and load resistance and the transformer off. Next, that is 0 point of the transformer. Next, in the second half cycle, the current will be flowing from B diode 2 and load resistance and 0. We can take it as a 0 or we can take it as a point O at the center tap. So these are the waveforms which is observed here. Next we will see the full rectifier with filter. Suppose when I am connecting the filter, what will happens? So basically the output of the rectifier is a pulsating DC. In order to get a pure DC, we are going with a capacitive filter. So what does the capacitive filter do means it will be charging and discharging. So the output will be coming like this. During the charging period, the output will be like this. And during the discharging period, it will be going like this. So my output, which is coming as an pulsated DC, will be filtered and the output will be given like pure DC. So this is the purpose of connecting a filter with the full rectifier. Next type of full rectifier is nothing but a diode bridge rectifier. You can see here 4 types of diodes are connected and the same input supply is AC supply. And the points which is connected between A and B is the supply, and the points which is connected between C and D is nothing but the load circuit. And here we can observe the waveforms also. So 4 types of diodes is connected and 2 types of inputs, positive off and negative off, will be going inside the full rectifier bridge circuit. And what will happens when diode 1 and 2 and diode 3 and 4 will be operated? Let's see. So you can see the operation of the full rectifier. You can see now. So when diode 1 and 3 gets operated in positive off cycle, means the positive off input is given through this supply and it will check the polarity of the diodes from A point and B point. In A point, you can see that the diode 1 polarity is positive and the supply polarity is positive. So the diode 1 gets forward bias, and the same way it will be connected to the D and load resistance and C and diode T3, and the circuit will be closed like this. Supply, the current will be flowing through A diode 1, D, then load resistance C and diode D3, B, and it will be going to the returning end of the supply. So when positive, so you can see the waveform. When positive cycle is given as input, output you can see here at the total output current, and the output will be for positive cycle. The same way when the supply gets naturally 0 and when it is returning to the negative half cycle, the diode 1 and diode T3 get commutated. It gets turned off naturally when the voltage gets 0. And next, when the negative cycle is entering, the polarity will be checked again. So diode 2 and diode will be checked here. Diode 2, it is connected with cathode, so this diode 2 will get forward bias and the circuit will be closing like this. You can see the current direction. This is nothing but current entering from B point, diode 4, D, load resistance, C, diode 2, and it will be entering through A into, and it will be reaching the supply end. That's all about the operation of a full rectifier. So totally for positive off cycle, the output will be coming, and for the negative off cycle also the output will be coming. My output will be a pulsating DC. So what happens when I connect a capacitor at the end of the bridge rectifier and how the output will be gives? Let's see. The same which is seen in the center tap transformer connection. The charging and discharging of capacitor will gives a will reduces the pulsating DC and the output will be coming like pure DC. These are my references, and thank you for giving this time to explain about the single phase rectifiers. Thank you.